organized by the Nord Foundation. And today we have the pleasure to have an international speaker that is going to talk about microcontrollers. Here we have Andreas, sorry. And yes, and he will introduce himself and he will start the presentation. Thank you for coming, Andreas.
Very. My pleasure. Does it work? Do you hear me? Great. Okay. So I will sit down now. Old man and things. So I'm here to talk about Rust and microcontrollers. But the caveat is that I'm not an expert. So you will get my glimpse, and my glimpse is a beginner glimpse, so to speak. Perhaps that is good for you. Perhaps that's too low of level. I don't know. Decide for yourself, or give me feedback afterwards. But I would really try to get a feeling who has done something with microcontrollers already. Oh, so you're mostly probably more experts than me. So I can learn a lot from you today, okay? And who's done a fair bit of Rust coding? Okay, then, okay. But yeah, so you probably won't learn much Rust today because it's just the usual stuff. But microcontrollers, perhaps the most value you will get out of the combination of the two, but we will see. So, and you are my first victims, actually. That's the version 0. So I did my best so far. I left something out, some parts optional. And you just tell me what you're interested in, and I will try to accommodate you as best as I can. I try. So what would I have in mind? And that's not fixed. You can say, I don't care about that, and we do something else. I don't know. But I would have thought, okay, perhaps let's do a quick introduction, because people seem to like to know people. I don't know. Then I would briefly talk about microcontrollers. I already said I'm not the expert, so I can give you the limited knowledge that I gained from toying and tinkering with that stuff. Then there is the combination part, where, okay, what is the Rust support that we have currently, and what can you use, and what did I use, and what is perhaps recommended from me, and I'm not an expert, like I said. And then there are the interfaces, which is kind of a bit optional. So we can talk about LEDs, we can talk about e-ink, we can talk about graphics, how do you display something on pixel devices, ink devices, whatever. We can do all that. And now to the dreaded introduction thingy. So my name is Andreas Bergmeier, blah, blah. I'm a software guy. So if I'm telling you that I'm not an expert, it's really because I am not an expert. I'm just a guy who likes to program, and I have some basic knowledge about electronics and soldering and blah, blah, blah. But I'm not the hardware manufacturing guy or whatever. I just try to tinker a little bit here and there. I actually don't even work in anything with microcontrollers. I work for, or I do mostly e-commerce backends. So that's, here you see, for example, I do stuff in Go, I do machine learning in Python. So that's more what I do on a day-to-day basis until I get home. And I work from home, so I get to the couch. And then I'm mostly at times do Rust, and then, I don't know, do microcontrollers perhaps. And I have been known to be a huge C++ and C fan back in the days. So most of my professional career was about C++ and C. And as you might see from this chart, I abandoned that a few years ago, so I'm not really a fan of that anymore, which is perhaps the reason why I'm talking about Rust today. Yeah, and but I'm also not the Rust expert. So I dabble in Rust. I'm doing some projects with Rust, but it's not like I'm the god of Rust and can tell you about every specific new thingy that's coming in the latest 2024 version or whatever. Yeah. Besides from that, I'm doing a lot of infrastructure as code. We do a lot of DevOps, the usual, so Kubernetes, scaffold, terraforming, blah, 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 blah. Yeah, what you need to do nowadays to get your stack up and running and make your code work, basically. And if I'm not doing coding and anything, then I'm doing woodworking, actually. So that's my go-to for not getting totally insane. So the saner part of my hobbies is doing furniture and other stuff. Okay, so let's quit the introduction and really start with some introduction into microcontrollers, actually. And here is for the people who really sense of why do I call this it's a microcontroller. Here is one line there. And what's different from a CPU? And from what I have kind of understood for me, it's a little bit combination of string processor. In what we have in these devices, you have more chips. So to combine them, you have a bus. With microcontrollers, you would normally, I guess, not have a bus. Also, what I gathered for myself, if I talk about microcontrollers, I would say, hey, it's a little bit less perhaps, it's a little bit smaller, it's a little bit more power efficient. And if I'm talking about a microprocessor, or for example, my laptop, it's bigger, it has more what it can do, and it also needs quite a bit of power to even run or even boot that thing. Besides, the booting is way, way slower on my device, usually. I don't know, would you agree with that? Is there anything where you would say, hey, I could add another specific thing about the microcontroller versus microprocessor differentiation? No? Okay.
Microcontroller is like just electronics or something like that, close to electronics.
Sure. But on the other hand, I mean, we program that thing. So it's still not just electronics, but yeah, it's closer to just electronics probably. So, okay, and why is it interesting to me? So if I'm just thinking about using a microcontroller, the question is, why am I doing that? I told you earlier that I'm not a C++ guy anymore. So most of my projects that I start for leisure or whatever, I say the rule is I don't have to do C or C++. I'm not dogmatic about that, so if there's a tiny bit of C or C++, I'm okay with that, but if it's all C and C++, that's not for me anymore. Back in the day it was. Currently, the devices that I want to build have to run on batteries. I do have our apartment pretty much laid out with Ethernet, but not every inch of the apartment or every centimeter. So there are some parts and some devices that I want to run on batteries, and I already said having these devices, you need a huge battery, and it's a huge pain, and I don't really want that. The other thing is, for me, I always kind of have fun tinkering with new stuff. But I'm also getting old. And with me getting old, I don't like to have as much pain with new stuff anymore. So what I tell myself, at least, is I like to stick to the beaten path. So I like to use something that somebody else has already used, and yeah, that's just a parameter that I have. And there's an asterisk there, and the spoiler is I'm not really sticking to my own rules, but that's a story for later. Wi-Fi matters. Like I said, I have Ethernet everywhere. I have power over Ethernet, yes-ish, but like I said, I want to run the devices on batteries, and also I want to have network connection, so I have to use Wi-Fi. You have, yeah, plus points if you have 5 gigahertz, 2.5 gigahertz is, at least where I'm living, it's a battlefield. It's like a war ground, and everybody tries to have devices sending on 2.5 gigahertz. So I would prefer 5 gigahertz, but it's going to need more battery, so it's a trade-off, and it's kind of problematic at times. I already kind of was a bit not too happy with booting, and I really like devices who boot in under 3 seconds, and I don't actually want seconds here. I want really just the device is just there. I want a device that's snappy, and want it activated as soon as possible. And like I said, I'm a software guy. I got to the point where I did SMD soldering, and I did not like that. So I don't want to do any SMD soldering. Sorry, no, I'm not into that. So whatever I'm doing, I'm kind of mostly trying to figure out a way to do that where I don't have to SMD solder. Soldering itself is okay. I'm getting okay at that, but I'm still not the greatest solderer in the world. I never will. I have no interest in that, and yeah, that's about it. So far, I told you a lot of about me, about blah, and now we get a little bit more into examples, for example. Sounds dumb, but okay. So microcontrollers. When I was not the first time introduced at microcontrollers, but if I'm talking about electronic guys, they always say, hey, there's this ASP 8266, and we have a gazillion of them, and let's use that. And we have, in my makerspace, what people then do is do Christmas lights and do funky electronics and whatnot. And for these kinds of projects, it's a very good microcontroller, I think. So why is it good? Because it's cheap, it's battle tested. So if I'm going to the part where I want to stick to the beaten path, then yes, that's it. There have been a gazillion programs written for that. Everybody knows the least bit or the latest bit in that, and people know how to do whatever they want. It's just a single core, and it's a RISC processor, which doesn't really have any meaning, I think. But yeah, that's just the specifics. So that's an extensor processor. So the interesting thing about that is that the people that I know, at least, who think about microcontrollers and the ESPs, is that these people do microcontrollers and electronics for 20 years or longer. So these people have been growing up or have done 1,000 projects. I'm exaggerating, but they have done a lot with these chips, so they know these chips. The caveat with this chip is that this chip is actually deprecated. So you can still buy it, it's still manufactured, but if you nowadays want to do a project, then they tell you to use the ESP32 variant. So that thing is supported, but it's not that easy. So I tried to, it's not the whole story, but as far as I understand, there are 3 big variants. So there's the C variant, there's the S variant, and there's the H variant. Interestingly, the C and H have the same chip. It's a RISC-V, the new kid on the block that everybody likes. If you go with an S, there's still an extensor chip in there, extensor instruction code. And so it's not like you can just use or just buy an ESP32, but you also have to have in mind, okay, what am I buying and what will then run on that thing? Because we will see later that that might make some difference. If we want one-to-one replacement of this chip, the old one, we then have to use the C3. It's cheap, not as cheap as the old one, but still cheap, and it's actually pin compatible. So every one of these pins should have the same layout as this one had, which also means all the C code, which I talked earlier, we have a million lines of code which ran on the old one. There's a good chance that you can port that to the new one. So from the upgradability, the C3 is probably the easiest variant. It also still have a microcontroller that support it. So far, any questions to these two
How do
things?
you compare Arduino to these chips?
Ah, good question. One does not simply choose a microcontroller. It's not that easy. So I already told you, yeah, you kind of need to know what runs on there. You kind of need to know this and that. And it's not that easy. So I told you everything here because that's my experience. So that's where I started with, or not even started, but that's lately what I have been toying with. And your question is exactly that. If we are talking about microcontrollers and especially about compatibility with Rust, we have a huge field. We have the ESPs, we have the ATmegas, we have the STM32, we have the RP2040, and I probably forgot 10 or 20 other of these. So choosing a microcontroller is like, I don't know, it's pretty impossible if you want to do it in an absolute way where it's the one truth. So basically, I would say you kind of need to look into what do you want and which characteristics are nearest to what you're trying to achieve. So what I did not initially want to do, and where the thing really kind of taught me that you have to do it, is read data sheets. You have to read data sheets over data sheets over data sheets, and really kind of dig deep into what can this thing do. What does it need in terms of power? What does it need in terms of how, or what does it provide, and how much pins you have? And it's not easy. It's not that I can, or I'm not able to comprise one data sheet where I'm telling you if you need that, go here. If you need that, go here, or anything. I can just tell you, hey, for the products that I'm currently doing, the ESPs are fine, and I'm telling you some other great things about them later on. But that does not mean that you will not have a great experience with an RP2040 or anything. And that's really the thing where I'm always kind of try to be very careful. I'm not the expert, so I can tell you the amateur side from my tinkering. That doesn't mean there's a whole other universe out there that may even better for what you're trying to do. And I'm just an amateur doing weird stuff at times. So, like I said, there's a huge universe. I just try to do 4 here, probably there are a gazillion others, and we will probably mainly talk about ESP32 because I do not know much, but I at least know a little bit about that. And also, when we are talking about which microcontroller you would choose, then if you have the same inclination as me and you want to, hey, I really don't want to do that with C or C++, and I want to use Rust, then you also, of course, have to look into, okay, how can I do Rust deployment of Rust code, for example, or how do I know how good it plays with Rust and all that. And that's also the research that you then have to do, which is not fun. It took me a while to figure that out, and probably I still haven't figured it out totally, but I'm at the level where it's good enough for me, and I'm not a professional, so it might not even, oh, sorry. It's fucked up again, but we can hopefully fix it. Let's see. Oh, right. Yeah, like I said, just the reading that you probably will have to invest in that, it's not trivial. Okay, if you now have all that information, then next, of course, is, hey, we can, of course, look into general compatibility, but if we go from the other side, from software side, so what does Rust support currently? And we have, and there's a lie in there. There's an error actually that I did not fix. Sorry for that. We did earlier see that we had for the ESP32. We had the two current supported chips, that's the RISC-V and the extensor. We recall that the RISC-V are the C and the H variants for ESP32. Extensor is the S. For RISC-V, there is some official support in stable Rust, which you can't use. Basically, but they have a lot of support already in there. For minor things, you will still need unstable Rust, but they are getting kind of close to have everything that you need in stable, but it's just not there yet. And perhaps it's even, I don't know. So that's not, at least was not a deal breaker for me, but it's still not, I'm just using the Rust that my distribution provides, for example, and I can totally start with doing microcontroller and programming. No, it's actually, you probably have to install it yourself and have to do some tinkering, and then it works. So let's do that nightly or whatever. I will correct that. And it gets even worse if we talk about extensor. It's not worse and worse, but it's more tinkering-ish. So there is landing, or sorry, it did already land. So some initial support for extensor already did land in LLVM. And as you know, LLVM then gets ported or further dragged along to the Rust compiler. But that's just an initial part as far as I know. And support for the latest features, and that's all a lot of features that you really need, is in upstream and at times, and of course not in stable yet. So we're not even on the finish line or anything. It will be probably years until we get there. And the bad news is there's no official Rust support for ESP 8266. So, I mean, it's bad from the side that you cannot tinker with the ultra cheap chips. On the other hand, it also means these also, I don't have the specifics, but they have that little RAM in them that it's really not fun. I mean, you could, if you really would try it, you could probably program it, but it's not really fun. And I kind of understand it. They deprecated that chip, and so there will be probably no official support ever. So if Rust gets support for that, it will be a community support thingy. And I think for that we are probably even more years until we have that. I mean, it doesn't look that great, but, and I didn't really write that here in detail, but there's actually official developers working on Rust for the ESP32. So they are paying developers to do the support. So now, guess where these developers are actually located in the world? Any guess? Come on. Probably. That's really cold. That's a really bad, probably somebody, yes, but actually in Spain. So you have actually developers in, I think, near Barcelona or somewhere, who actually do the support, and they actually wanted to come, but they are on vacation currently. So that's why they are not here. But there are developers actually in your neighborhood who kind of try to get, or who are paid to get the Rust support on the way. And that's for me also a confirmation to still use the chips, because I know the support probably will get better. And if somebody gets paid to write Rust or do Rust support, and they also answer my dumb questions. So, so that means I get support, and I love support. I love people who explain stuff to me because I'm too dumb. And so that's, for me, one reason to really stick to ESP32, unless I need something else, which the microcontrollers cannot do. And one does not simply program Rust. So even if we now go ahead and say, okay, I want to use the microcontroller, you convinced me now, Andreas, I want to do that, then there are three big ways, I think, that you can do it. So the one thing that you can do is you can use the STD. If you have done Rust on your laptop, there's a good chance that you did STD, which basically means you use both crates. You use the core crate and you use the standard library crate. If you do the no STD thingy, that means, of course, you don't have the standard library, and you just have the core crate. There is a book for that, like for everything in Rust. And it's actually quite good, so I have the link in here. But that basically means you have to do everything yourself. So, I mean, everything. Mutexes, I don't know. Everything that you ever have done, basically, you need to do yourself. There are libraries to do, to help you with that. But it means that you have to include all these libraries in, and you really need to know how they work. And it's even more involved than just studying Rust programming. So I'm like I said, I try to be more the beaten path guy. So I'm currently just using STD. So there's really not much that I can tell you about NoSTD. I can tell you that I tried it and it was a pain in the neck. So I'm not doing that currently. And for me, there's no reason to do that. But if you do a really, I don't know, ultra low level, a lot of, I need every bit of RAM that I can have to do some computation, perhaps then no STD is great for you. For me, STD was good enough. And I hope this will stay that way because I already, have too little time anyway. So, and sure. Oh, that gets frequent now. Okay, let's do that. And we're back. So yes. Sure.
What is the advantage of using NoSTD?
That you also don't have to use the standard library. I mean, the standard library is probably not bad per se, but it has some overhead that you might not want. So I don't know, perhaps it's the way allocations are done. Perhaps it's the way you want a Ethernet stack, but only for certain scenarios, and you don't want the rest to have in RAM or anything. And that's just me talking about what could be, and I'm not even using that. I think there are reasons to do that, aside from tinkering. Tinkering is always a great reason. But I think there are reasons to do that. Like I said, I try to use it, and it's really painful for somebody who's not an expert. At least it was to me. And I think the level of expertism that you need is just going straight up if you use NoSTD, I think.
Okay, so for your own stuff, STD is fine.
Yeah,
I mean, it has the
yeah. Luckily, because quite frankly, I probably would have given up if NoSTD would be necessary for my stuff. But I'm also, I would be kind of dishonest probably if I would tell you, yeah, start programming Rust, because the question always to me is, what do you want to do with that device? So perhaps the spoiler alert is I want to have a device with an e-ink display, which syncs with the web and stuff. Which is not the basic, typical use case. For example, if you just want to have a sensor or multiple sensors and perhaps support for Meta or whatever kind of interface is there, then maybe even coding is not the right thing. There's this platform ESP Home, which they provide for doing kind of no code, if you will, integration of sensors or other data. So if you just want to kind of get data from A to B and read some thermals and I don't know, some light values or whatever, then maybe don't even try to do Rust. Just use ESP Home and be done in 5 minutes, perhaps. So that's just, I mean, I really like coding, but at the end of the day, there's just so much time you have. And so even then, I think you should at least think about, okay, there's this other non-coding possibility that works for sensors, for example. And here's the website, I'll link the website, and there's also then a way of getting or talking to the ESP Home from Rust. So you can also then do the Rust perhaps and control it with Rust, and then you have your Rust again. But still the microcontroller then might not need to be coded in Rust. Like I said, I'm using that one. And then we are, I mean, I already talked about it, but still, to drive that home a little bit. So if we look at the crates, then we already saw if we are at STD level, if you will, then most libraries should work because, I mean, that's the standard library. That's the jump-off point of anything in Rust, basically. And then there's the caveat. If any of your crates interacts with C or C++ or whatever, then you might have a problem because that means that search paths, defines, cross compilers, they all need to work. My thingy would be RISC v32. If you would use the S variant, it would be the extensor, which would mean that you need the cross compiler, for example, for extensor. And you need to have all that in your development environment or it will not compile. And which would not be that bad if it wouldn't be transitive. So so the great thing about Rust is, of course, or not the great thing, but I think there's really limited support for shipping binary-only crates. I think there's some support has landed by now, but I'm not sure about that. But for most of the things that you code with Rust, it's source code only. And everything gets generated once you put it into your dependencies. And then there's, I don't know, a source RS or whatever, or build RS, which takes that, searches for the C headers, generates automatic bindings for Rust, and makes that available, and then you can compile all that and whatnot. And this will hit you for every single crate that is in your dependency transitive tree. And that's actually where I'm currently stuck. Because I tried one thing, and it had the deep down transitive dependency, and that crate does not yet work with the cross compiler for RISC RV32. So just caution, even if you have STD, it's fine on the Rust level. It's not fine on the C level. So that's where you have to be careful. If we now, for completeness sake, then we have the black hole, because, I mean, for no STD, nothing will work. I mean, that's exaggerated, but it's like the STD is not there. So I think for a lot of libraries, you need STD, and you from the get-go can only use crates that are specified as no STD, of course. No STD libraries, on the other hand, should work because, I mean, it's the same thing. You depend on the core crate, and the core crate works. Okay, fine. But you have the same problem. As soon as something transitive in your dependencies interact with C, platform headers, whatever, you have a problem. Or you might have a problem. There is probably still or yet enough of the C libraries and crates who kind of already can make do with that, but I at least hit already some which can't. And it's not like it's impossible, but somebody has to do the work. So either you go ahead, or you go ahead, or you go ahead. So I'm picking you now. And fix it. Or you have to be really nice to the maintainers and buy them cookies or whatnot. But somebody has to fix it if you really want to use it. So that's also, you have to keep in mind, if you really want to use Rust. And then if you read around the metrics, the metrics channels, they will tell you about Embassy. And I will reset. Yes. And I just copied it out. I mean, it's pretty self-explanatory. Also in the embedded world, you also can have or want to have, I don't know, async Rust. So async Rust, you know, is the latest and greatest and whatnot. I'm not the greatest fan of async Rust personally, but I do understand why it makes sense in some places, yes. And basically, Embassy is what enables the async Rust mode for microcontrollers. So that's a framework which basically exposes certain structures or extension points where, for example, the support for ESP32 can link into or can use to say, okay, you have to use this one if you want to use async functions or whatever. Yeah?
So I understand that there's no RTOS support for the Rust ESP32 toolchain. So would this be the closest thing to an RTOS?
It depends. I don't think it's really about the OS thing. It's more about the way you write your Rust code, because basically what you then do with the async functions and whatnot, that's totally up to you. So you can then use them to do a real-time processing. You can do it in a way that you say, I'm waiting forever for a web call. So I think that's basically up to you. On the other hand, whether it then is possible to kind of bind that to RTOS, I don't know. That's not what where my expertise are. Sorry. But basically, what you can then use or do is you can have your Tokyo code, like you would normally do, perhaps, and you can also use that embedded, which is nice, which brings you one step closer to writing normal Rust code, even for microcontrollers, which is not that bad. Yeah. That's where I would have stopped with the state. Is there now a burning question? Or we will look at the stuff later on anyway, perhaps. Then I would just continue. So, because that would all be too easy. Come on, you agree. It would be too easy, right? Okay. So now that we all agreed it would be too easy, no, it's actually a good thing. If we are now getting on my level, so a guy who just wants to write Rust and who wants to use it using the STD mode, I don't know what it's actually called, then somebody needs to do the work. Somebody needs to implement the standard library. And if you want to have the standard library for the ESP32, then you use the IoT development framework. And it's not that you do it explicitly and implicitly. It sounds weird. So if we are going into the home page, so that's the general guide for the development framework. You can look at the API reference in your own time, and you will see that they implemented a gazillion things for interacting with different protocols, with different hardware thingies and whatnot. So that's the jump-off point if you want to have STD. They did all the work. So that's what enables you to use the STD. But you also can kind of imagine probably that there is some overhead and you have to probably to compile something in, which is bigger than you would have if you wouldn't use all that. So it's great, but it's also a lot. So I probably know about 5% of all that's listed here. And if you want to become an expert, you really have your work cut out for you and have something to do. But I think it's really, to me, it was a great message, let's put it that way, that work was already done. It was done mostly for C. And they have, for most of that stuff, they have bindings for Rust. So I don't know how long they did the C development yet, but the Rust bindings are growing every day, every, I don't know, week. And so you get more and more of all these things for free, basically. There's one caveat, but we will get to that later. I will do my best. Okay. So that's what enables us to use STD. And I realize I do kind of make perhaps me sound like a ESP fanboy, but they also have even more stuff. So if we now look into what they have here, and did they restructure that? I don't know. Maybe they did. Let's just look here. Okay. It's a bit slow. Yes. So here is the SDK. We of course are interested in that chip here. And yeah, then there's modules, dev kits, whatnot. And sorry, here, sorry. Yeah. And we looked at that thing. I know 5% of that thing. I know nothing about everything else. So if you want to use Matter, if you want to use it with Arduino UI, the thingy, if you want to do a mesh, integrate in HomeKit and whatnot, there's a lot of stuff that's already available. Some of that is also available in Rust. Since I'm not using it, I cannot really tell you how much is already available, but there's a good chance that something is available. So I think that's good. But like I said earlier, if you really want to use that, you have to dig in and see what the state is and whatnot. Yeah. But there's a lot of work being done. That's probably what I want to say. To really make the development experience, or the capabilities probably, the capabilities for the ESP chips really good. I don't know whether it's easy to get into that. I don't think. But the capabilities is there. So now I have told you about what is possible, perhaps, and how did I start? I can just tell you how did I start. So DevKit, right? I mean, that's the thing that you probably want to do. You can buy, I have also bought, just to see what the difference is, the microcontroller without DevKit. You can do that. I would not recommend it for the simple point that, at least for the ESPs, the dev kits are already so tiny that doesn't seem to make sense, really, to me at least, to buy anything else. Unless, of course, you are more in the electronic space, then you might really want to do, I don't know, to just connect the pins that you really want and need and whatnot. For me, I have a few dev kits here at home, and they are fine. So I don't really want super tiny devices. I have big hands, so they need to be big so that I can touch my devices. So I am fine with a dev kit, and you kind of can see how little one of the regular size dev kits is. You can get really one that's as large as my thumbnail, basically. And that's what I can handle with my hands. Anything more fragile, and that's not working for me anymore. And spending money, great. So the one thing that you really need to kind of look into is, at least it depends on your setup, but do yourself a favor if you are on the USB train already, USB-C train already, sorry, and get a dev kit with USB-C. There are a lot of dev kits already with micro and whatnot, and it's really annoying to have to plug nobody really wants that. So for that, I would really recommend buy something which has already USB-C, or maybe if you are on the old train still, then it's fine. Yeah, all good. Rust, I mean, probably most of you, I don't need to tell you how to install Rust. There's also probably a gazillion resources on the internet, and you can just install Rust up, get your latest Rust, and be set up. If you don't find how to set up Rust, there's also the book. Sorry. Let's have a quick. Are you my friend? Yeah, you're my friend. And there's also the book about, hey, how do you start with STD? How do you do with training? And they tell you a little bit about all that. Also, which books you probably should have read already and should read, how you set up your project, how you organize all that. It's all in there. It's pretty okay for the first steps. I'm somebody who really likes to get explained why you do things, and it's not always good at explaining why you do things. It's just do that, and do that, and you're happy. That's not for me. I really like to shout into my computer then. So I'm always getting a little bit frustrated with these things. But you can also see one thing. If you look at the crates where they tell you to use, there you find the IDF. So the IDF, basically, in my naive concept, is you can always replace with STD. So if you use, for example, you use IDF-sys, IDF service, or IDF hell, it basically means all these are there to provide you with the STD capabilities, basically. Hell, not so much, but these rather. And yes, you don't really have to be super explicit about IDF, but you still need to reference them by name. So yeah, that's the most of that what you will need to know about IDF. Of course, if you have it in, then you need to at times look at the symbols that they are currently exporting in your version and see what is available in contrast to what is available in C. And then you can go from there, basically. And then I don't think there's any way around it. Then there's embedded HAL. HAL is the hardware abstraction layer. There's also perhaps a thing where you would kind of have a reason to go with no STD. If you say, hey, the HAL is too abstract and too verbose for me, perhaps I don't want a abstraction layer. I want to do it directly with the hardware that I have, with all the specific knobs and handles. But for embedded, there's an HAL. I use that because, like I said, beaten path and stuff. And the HAL also does expose a lot of HAL thingies. They also tell you how to set up the tool chain. Most of the time it's okay. I managed to shoot some workspaces in the foot already, so it's not like you can't mess it up. But I mean, you will figure it out. Yeah, and I mean the rest is read that, follow that. That's fine. I mean, it's pretty boring stuff. So, the interesting thing for me as a beginner was that up until that point, I wasn't even aware that you could pimp cargo. So you have in there, they will tell you that you can expand cargo with another command, that's ESP flash. So you do cargo install cargo ESP flash, then you need some other packages too. Then you can just go cargo ESP flash, and then it flashes on your microcontroller. And I'm not so much a GUI guy, so a lot of people use the Arduino GUIs. I cannot stand that stuff. I'm really far more happy with just having to do cargo ESP flash, and it just deploys and it's ready and it's going. Really like that. Yeah, brush my teeth is not included, so it does a lot, and it automatically builds, it automatically checks, it does partitioning if you want, but it does not everything. So you still have to be a little bit careful at times, but most of the time it's fine. And create project, there's kind of what where my time preparation time ran out. So there's also basically the instructions where you would follow from that. So if I think now that you have followed the book, then one thing the book will tell you, and I will tell you too, is if you have set up your environment, then you have the simulation. Because, I mean, bringing that thing to the coffee shop every day or whatever is mostly perhaps okay, but perhaps you don't want to, or you don't have it with you or whatever. And then you, rather than having your ESP really with you, the hardware, you want perhaps just simulate that. And there's the Wokwi project. And they provide you with a free system simulator, which does surprisingly much stuff. So you see it here. It supports STM, Arduino, Raspberry Pico, whatever, and some sensors, some motors. So it's more than I would have expected. It works okay. You can use that. I'm at times a little bit dumb, so the docs are not crystal clear, at least not as clear as my dumb head would need it at times. And the one caveat is I even gave, you can buy a subscription for them, with them, sorry. And I did that. I think they are doing a great job, but there are bugs in there. So use that. If you have errors, it might not necessarily be your problem. It might also be, or your bug, it might also be a bug in their software. And but they are really supportive and try to debug with you where the problem is. So they do great work. Sometimes it just doesn't work out. So I would really support them. Yeah, if you want. So now, that's basically where my nicer presentation ends, and we can now go into the wild west of my knowledge. Sorry, I don't have fancy slides anymore. So I thought perhaps I'd just give you a little glimpse about or into what I am working on, and you then tell me what you're interested in, and I can talk more about that. So it's loading, sorry. So here. So what you see here is the microcontroller. I borrowed that from my daughter, actually. That's the microcontroller. You see here, it's hooked up to a micro USB, I think. And you see a lot of cables going out of that for all of the pins. So this thing is now, so you can see the variants, whatever, blah, blah, blah. All these cables are going into a driver head for e-paper. Do you have, is everybody clear on what the e-paper driver head does, or what it's for? Okay. What you have on the one side, you have your device. In this case, it's an e-paper, e-ink, whatever we want to call it. And on the other hand, you have the microcontroller. So challenge is, of course, these two need to speak to each other with a protocol, whatever. And now we have a few options, let's put it that way. So either you have a really, really simple protocol where you can go, where you can't really mess up, and where you have very few data lines, and you can connect them directly, and it can all work. In this case, that's not the case. So you see it here, or that's one case. So you can already see here. Here is the lever where you can switch which protocol you, or how many lines in the protocol you want to use. So there's SPI, which is a serial protocol for communication between the two devices. But you can have it in different variants. So you can either have it in 3 lines, or you can have it in 4 lines. And for the communication to work, yeah, you need to select which lineage your code uses. So it's not, and that's the big difference, I think, from if you compare it to this device. If you have done Linux kernel development, for example, there is a gazillion lines of code to make sure that every permutation that you have in your devices works with every other permutation that might be exposed. And for microcontrollers, mostly it's not the case. It's just the case that there's one way this thing should work, and you need to use one this one way, but you also need to make sure that everybody else uses that one way, or the one ring, depends on what you want to call it. And in this case, it's a board which is for that. You can tell it now here, do a 4-line, do a 3-line, and if you do, for example, here, you have the 0, which is 4-line, your code does 3-line, it won't work, period. Which makes the hosting very efficient, because you don't need a gazillion lines of, or gazillion bytes of Linux kernel handling, for example, but you cannot fuck up anywhere. So if you fuck up anywhere, then it's not working. And I mean, I'm not the expert, but I did have some debugging sessions where I did some errors, and it's not pleasant. It's really, that's the one thing I really don't like about microcontrollers. But yeah. On the other hand, for this controller, you can't really see it good here, but I can tell you, they are using SPI, like we already said. But they thought, well, SPI is too boring. Let's extend SPI with some other data lines. And so this kind of thingy now brings together the SPI lines with the alternative data lines and configures them or makes them available. You can read it here. Truth be told, you have to have some knowledge about the different protocols and the kind of the description that they use here. For example, there's the DIN, and DIN can be, I think in this case it's, is it MISO? I think it's MISO. Is it Mozzie? Yeah, you might be right. It might be a Mozzie in this case. But I didn't know that before. So I had the DIN. I was there and was really like, okay, the DIN, and I was Googling and what the fuck am I doing? And they, of course, advertised, hey, we have an SPI. And I was kind of trying to get all that together with SPI. And it wasn't working, and luckily I know some people who kind of are, who know these things, and they also were puzzled initially, and then we figured it out. But yeah, that's the challenge of that. So you see here, there are even more configurations that you can do. In the end, there's the cable, and that now runs directly into the e-paper, and then you have hell rust. So that was the first time I got everything running, got the whole stack booted, and could then write from my code directly on the e-ink, and that was really great for me as a software guy. Yeah. And rust. So actually, yeah, we don't need that anymore. So now, one thing I wanted to talk about, but that's now totally up to you. So we can talk about challenges. We can talk about protocols. And we can have questions, feedback, or whatever, of course. Yeah, and now it's really kind of up to you. What's the most interesting part that you guys still want to hear? I already am babbling for more than an hour.
Yeah, maybe for a start, what you are trying to achieve now?
Sure. So, here. have children. I have children.
Okay.
Children at times have some problem with getting their chores done. No, not that bad, but it's just you remind them, hey, put your books into your rucksack for school or whatever, and it's all the same, all the same. And what I thought, okay, what I want now is I want to have an e-paper display, which is connected to a microcontroller, which then we use at our family we use Google. Sorry for that, but that's just us. So that's sorry. No, let's say Google Keep. So what we want is a microcontroller which reads a to-do list or some thingy reminders from Google Keep, goes ahead every day, syncs that, displays it on the e-paper, and yeah, let's say here 6 o'clock, something. And at 6 o'clock displays everything which needs to be done, or whether the kids can't really, or which they should not forget, on the e-paper. So really want that to hang on the walls, say, hey, look at your thingy, and then they know what they really have to think about or before leaving. That just was, we started with that on an analog way, and that's not scaling. That's you really the need to use something new. Okay, then you are redrawing it or doing it differently, and at that point I was like, okay, this should perhaps be really pretty easy with an e-paper. I forgot, and then a want, and that's because from an earlier project I have still some these lying around are buttons. So I want them to then also be able to kind of notify, have the buttons, and then everything that they had to do gets synced to Keep, and it's also already notified that it's done and they can do that. That's what I'm currently trying to do. So I have the e-paper, I can do that. That's actually where I'm having the problem currently, because somewhere deep down in the HTTP library that is accessing Google Keep, they do not yet have access for RISC-V32 via the build RS, and that's probably one thing I need to also look into, because somebody has to fix it, and if they don't have the devices, then probably it's me. That's what I'm trying to do. So I think I haven't prototyped that yet. That should be easy, but maybe it bites me in the ass. I don't know.
Should be the easier thing.
Hopefully. So I'm currently betting on that. So I'm betting on that buttons should be easy, so I'm not prototyping it. I'm not really sure whether this is a good idea, but okay.
Should be the easy thing, just a matter.
Yeah, should. But we'll see. The other thing, and that's the asterisk that I did at the beginning. Let me show the code. So now we're off the beaten path. So now I can show you. I have two. I know I have too many projects. Don't tell me. I know that. So. And I caved at some point. I just used Visual Studio Code anyhow, because I couldn't really keep up with configuring Emacs anymore. So that's the thing. And you might wonder why there's so much code in there for just displaying something on the. So basically.
You have a light thing.
totally right. I'm making it bigger, and then I am trying to do the... No, sorry. I think it should be in settings, right? Light,
I think it was in your previous menu,
right? Okay.
or no, in the old menu on the left. Yeah. Then you go to where you were.
Yeah.
You go to preferences, and
Okay.
almost at the bottom there's theme. Yeah, on top of color theme.
Mhm.
Oh, white lights, one of them.
White light, perhaps?
Yeah,
Well, yeah, change later.
Andreas, maybe you need to plug your laptop. It's going to get up without power.
No, that's still okay. It's 30 minutes. That's okay. But thanks. I at times forget that. Yeah. But I mean,
Okay, thank you.
we really should probably at some point stop with my insanity. But okay, there's a lot of occult in there. Let me perhaps go through that. So. What I found very confusing initially was that everybody and their dog was using the word driver. And it's totally justified, but it's kind of mushy what a driver then is. So basically, I think a driver is just something which talks to hardware or does make some hardware do stuff. But we also already saw that the connector was a driver. Here we have different parts who say they are a driver, so that gets a little bit mushy. But here, at least, here is the display, and that's an abstraction. What you can do in terms of operations for the display. So in this case, you create through the width and the height, and the color, you create a buffer, and you can then render that buffer out onto the device, actually. And somebody will probably notice that there's a box around that. Any idea why there's a box around that?
To place it in the heap.
That's a win. So it doesn't need to be on the heap, but it's better on the heap. You can at times, if you have larger buffers, you can make it work on the stack, but at times you get problems. And if you have problems, it basically means the device just restarts. So there's no rails or anything to guide you. It's just restarting, and you have fun figuring it out why it's restarting. So in this case, I'm now at a point where I'm pretty paranoid. So for every of these structs, I'm looking into the implementation, looking what they are actually doing. But because at times it's I think a little bit surprising what they are trying to do. But in this case, it was pretty easy. I've put it on the heap, have fun, and everything's great. Here, you already saw in the video, everything was pretty much white. Here I say clear it over with black, which basically means at times that the colors are switched. Yeah, that's great, but like that. And then you can have a picture layer, but that's for later. And then usually what you do with if you do embedded drawings, you have this embedded graphics. Great. And this provides you with stuff like, hey, draw a text, and you already saw the hello Rust. and that works fine. So if you have slight insanity, like me perhaps, then you want to have something better, and you want to have a nice UI, and then you would like to have something like I have here with layouts and whatnot. And as far as I know currently, there's just one crate who implements anything like that. Probably there are more, but I didn't find them. Period. So either you write it yourself, or you look at the other crate, or you search a little bit more on Google. The easiest I found was just going in using whatever the embedded graphics provides. Not much, but has to make do for my experiments. Yeah, and it's pretty easy. Yeah, you say where it should display anything. You say, okay, draw it, and afterwards here it draws on the display. Then the buffer was updated, of course, with the text, and then you just draw the complete buffer and say, okay, display it and update on the device and display the frame. Which, yeah, I don't think we should do it now, but what you will then see is that the screen will blink a few times probably, because it will try to clear all the pixels first, and then we'll draw the actual content. So there is a partial update, which I don't use because I don't need it, because I just want to refresh it one time a day. There is a partial update, and that's probably rather what you want to do. So just update the pixels that you know that you touched, but for that you need to then again remember what the old state was, and you need it to a diff and stuff. It's too much for my my project, but if you want to do that, then you have to do a little bit more logic. Then here, you don't have to do that, but just for being really correct, I said, okay, then wait until everything via SPI was delivered and acknowledged to the display. Wait until that is done, and then display text. Note here that I didn't have to do anything special. I just had to use the log crate. So since I'm using STD, I get all these things for free because it's STD. And that's, in my opinion, the great thing about this, because I really can focus on what do I need in terms of functionality, in contrast to having to worry about how do I print debug messages and probably even more nasty stuff. And it's pretty bad here because I'm using from the old project. Let me perhaps show the little less confusing. I have too much project, I know. The Christmas ball, and I think Christmas is not that recent, so I'm trying that. Let's see. And there's also Walkway in here. So that was another project I did with my kid, and it's probably a little bit easier to showcase some stuff. So all that, what you see here, is probably or is definitely what in the books they will tell you. They will tell you, hey, you need to link some patches, you might want to initialize the logger, but that's just following the default, and there are even templates for generating this kind of project. Then what I did here is have a Christmas ball. So the idea was to have the Wi-Fi, and you can connect to the device via Wi-Fi, via hotspot, and you can then change the color of the Christmas ball. So and that really tried to do every variant that is supported. So here, these are anode RGBs, these are cathode RGBs. There's a protocol for LEDs, so it's, I don't know, a higher level protocol, so to speak. So these are pretty raw, and there is the thing what you would use for more sophisticated stuff, perhaps. Yeah, and then I wrote some driver for the anode and cathodes, and then really that was the point for me to really learn about all that and how do I configure that and how do I structure it at times. And here's the Wi-Fi, and then you can here have the requests, and then here you have the LED cursor. So if you submit, you get a form, and here you just do a URL encoding, read out the new color that you want, and then you just parse it and set it on the other end. Also, this taught me also a lot about mutexes and trying to get all the memory access right. Yeah, here is the response that you get. So there's just a form.
In which screen are you showing the form? Here you are showing HTML form.
Mm-hmm.
Okay. You're just connecting with a computer to the...
Or a smartphone or anything, yeah. You just connected it. Then that's the one thing where I said I don't care about it anymore. But you then have to, of course, enter an IP and stuff. So it would be nicer to have a DNS, but I didn't really care about it anymore. But yeah, then you can just go ahead, have the LED colors, and submit it. And that's all. That's a good thing. Here already, all of that is supported in browser. You just have to have a handler for the response that gets then sent to the browser back. That's also pretty easy if you have STD. You can just use that. It's not the best code in the world probably, but it works. And so you have a Christmas ball, and there are a gazillion LEDs around that, and you can then, the kid can do a selection of different colors and stuff. So that was a nice starting project. And based on that, did now the other one. And yeah, so I'm getting more complicated. So, and the final sign of my insanity was, of course, the point where I'm at, where I thought to myself, okay, I can render the text now, which is, we saw, it's nice and all, but I want a sophisticated layout. I want something like here. I want something which is pleasing to my eye and nice. And what I then did is kind of researched, okay, how would I do that? And then I went down the rabbit hole, and basically, in my years, I've seen some GUI frameworks, and there is a lot of criticism I have for a lot of them, but the thing that I like more, or where I don't have the least critic, let's put it that way, is actually Flutter. And what I then was like, okay, the good thing about the Flutter is it's documented. So what would happen if I would have something embedded for the e-paper thingy, where I could use something which feels like, or which handles like Flutter, but also works for my project. And with that, then I started here, going down the rabbit hole, what you see here, and I started implementing Flutter in Rust. Don't do that. It's a bad idea. But that's what I'm currently doing. So the asterisk is really the asterisk because I'm at times really playful and like to tinker with things, but it's just too much work and it's ridiculous. But it's really interesting to kind of get more into the depths of Rust, how you would port that on the embedded variants, and how you can make that all work. And that's currently where kind of yeah, having my fun with. It's also for me really great because it teaches me a lot about Rust actually. So having to kind of make something which was initially or which was thought about, hey, this is pretty much class derivation, mix-ins, whatever, and now bring it to Rust where you have a component-based system. And how do you mix all that? How do you bring that together? And how do you still be able to use the documentation? Because if you go straight too far, then the documentation isn't worth anything anymore. So you have to be similar or the same with the documentation while still kind of piece to what Rust is providing for you. And that's probably where I will be busy for a year now, until I either give up or have maybe a prototype. I don't know yet. I will see. Yeah.
Why did you, let's say, run away from C and C++, and did Rust fulfill that role?
How much time do you have? Yeah, it did. It did and it didn't. At the time, the short answer is Rust didn't, but Rust and Go did. So Go does some stuff good enough that I don't want to use C or C++. And for the rest, I can use Rust, and that's a combination that I really like, using the strengths of both. And that basically got me to really not try to use C and C++ anymore, aside from all the problems that you have with C and C++. I mean, the problem that I talked about earlier was the search paths, the compilers that you need, all the insanity, because there's no standards, there's nothing in C and C++. And there's standards for Go and there's standards for Rust. And they work. Everybody adheres to the standard and it works. Nobody gives a crap about standards in C and C++. So that's just, I have limited time on this earth, and I at one point decided, okay, my time is not worth figuring out the gazillions problem with search paths in C++ and setting up, I don't know, CMake, Bazel, or any other system. It's gotten, for me, to a point where I wasn't like, I'm not doing that anymore. That's the answer. With that, my rambling would, or my computer is telling me my rambling is over. Yeah, thanks so much for listening to my ramblings. I hope it did bring you anything, or maybe you can use something. If not, I'd love to hear from you on the next meetup in Hamburg. What do you do for fun? Thanks so much. And I have to say, so the thanks is really to Sergio Gasquez. Sorry, I butchered the name. who is one of the guys who does the ESP support, and he helped clarify some of the content. And so I hope the content now is a little bit better, thanks to him. And with that, I disconnect.
Give me the microphone. Yeah, because like, this is still recording.
Can I do it? Yeah.
Thank you for coming, Andreas, and for the talk, and we finish here.